So this is part 2 of our graphing with the transformation rules. We are now on problem number 3, and the key to being able to work with these types of functions is we need to know what the parent function is, we need to identify what the transformations are, and we need to know the key points of the parent function to help us draw the graph. So the first thing that we need to look at is, what is the parent function? And hopefully you recognize that it's y equals 1 over x. The nice part on this one is that we only have 2 transformations, but the first things first, we need to get the key points on this graph, which are a half, 2, 1, 1, and 2, 1/2. And remember, even though my picture already kind of looks like it touches the y-axis, we don't touch the x-axis, nor do we touch the y. And we also have points -1/2, -2, -1, -1, and -2, 1/2. And there's our parent function. Again, we only have 2 transformations. The first transformation is occurring because there's a negative outside of the function. And when we have a negative outside the function, how does that transform the function? What does it do? Well, it reflects over the x-axis. And again, you can't see it on the video, but sometimes flipping your hand over the x-axis flips the graph in your mind. So it just depends on whether you are a kinesthetic person like that. But in other words, the first point we graphed was a half 2. Now it's going to become a half -2. And our point was 1, 1. When we flip it over the x, it's going to become 1, -1. And a 2, 1/2 is going to become 2, -1/2. Flip over the x-axis. We have the other branch to do the same thing. -1/2, -2 becomes -1/2, +2. And -1, -1 becomes -1, +1. And -2, -1/2 becomes -2, +1/2. And there we reflect. Lastly on this one, the final transformation, there is a +3 inside the function. How do we move with a +3 inside the function? Well, we're going to end up going not right, 3, but left, 3. So everything's going to move 3 spaces to the left. So -2, 1/2 is going to move 3 spaces left. And -1, +1 is going to move 3 spaces to the left. And 1/2, 2 is going to move 3 spaces to the left. So we get this. And then we have our other branch. 1/2, -2 is going to move 3 spaces to the left. And 1, -1 is going to move 3 spaces to the left. And 2, -1/2 is going to move 3 spaces to the left. And there's our picture. Number 4. 3 times the greatest integer of 1/2. 3 times the greatest integer of 1/2 x. Let me say at the beginning of this problem that this graph is hard to see, at least on the smartboard, because it's so small for our steps or our floors as you think of this function. But that double bracket there indicates that it is this function. And again, very hard to see this on the graph. I'll do the best I can. I do not have a fine enough point on this pen. And then any disorientation messes it up as well. And in general, what I'm trying to draw in, and I'm going to erase it and just drop down here for a second just to kind of get you going in the right direction. But remember, we've got like a solid circle here and an open circle there. And then we go up to 1, and it's a solid circle there and an open circle there. And a solid circle when we go up to 2 and an open circle there. That's the pattern on here, which is very hard to see, at least with the parent function, when I draw it. And I'm going to pause the video for 1 minute and orient again. So let's try it one more time here. A little bit better. The nice thing about this kind of function is once you find the pattern, you can draw them in all day. I usually do 5 or 6 steps, but roughly something like that. Very hard to see. But can we identify the different transformations on this graph now that we've got that? And the first transformation is coming from the 3 that is in front of the function. Well, when we've got that 3 in front of the function, the transformation is going to be a vertical stretch by 3. Remember, vertical means that we're going to affect the y values. And we have a y value at 1. We have a y value at 2. We have a y value at 3. We have a y value at 4, at 5, at -1, at -2, at -3. The first step isn't going to change. It's still going to be on the x-axis, and that's supposed to be an open circle there. But instead of going up 1 space now, we're going to go up 1 times 3. So our next step is going to be up here at 3. And instead of going up 2 spaces, we're going to go up 2 times 3 because of that vertical stretch. So it's going to be 2, 6 is where we're going to start our step. And once again, on this particular function especially, once you get the pattern that we're taking stair steps 3 at a time instead of 1 at a time like we did from the parent, we can continue the pattern down here and down there. Very hard still to see on this graph. But we've got a step at 0, at 3, we went up 3 spaces, and we went up 3 more spaces. I also went down 3 spaces and down 3 spaces again. And finally over here on the third transformation, you might be able to see it a slight bit better, because our third transformation is going to come from the 1/2 that is inside the function. And inside the function indicates that we're going to have a horizontal And because it's 1/2, we're going to take the reciprocal of 1/2. And the reciprocal of 1/2 is 2. So that means that we're going to have a horizontal stretch by 2. And the horizontal impacts the x value. Again, horizontal stretch by 2. So now our x value is going to change. And if you look, our steps in the previous 2 and the black graph on the orange graph, they are 1 space long. Well, that x value is going to change now. And now our step is going to be 2 spaces long. So we can almost see this one. We already put in the vertical stretch, so we're just doing the horizontal. So our steps aren't going to change in terms of where they are. So we're going to go up to 3. But now they're going to be 2 spaces long instead of 1. And then we're going to go up to 6. 2 spaces long instead of 1. Again, once you get the pattern, we could draw as many steps in as we want. They just need to be horizontally 2 spaces long. So we've got a step at -6, at -3, at 0, at 3, at 6. And there's our greatest integer, our step function, our floor function. The rest of them will be a little bit easier to see. Remember, what's critical is, can you get the basic picture with at least a couple of key points on the graph? So here for our parent function, we have y equals log of x. And remember, we're not going to touch the y-axis on this graph. And I have to stop and think about the points for a minute, but they are 1, 0, and 10, 1. There's our graph of our logarithm. That's our parent function. So if we can figure out the parent function, we can remember the key points, we have a good start. And then we need to identify the transformations. Well, our first transformation is the 2 inside the function. So when the 2's inside the function, we need to take the reciprocal of that, which is going to leave us with a horizontal compression. And it's going to be by the reciprocal of 2, which is 1/2. And the horizontal impacts the x values. So when we look at this, instead of 1, 0, we're going to multiply 1 by 1/2, and we're going to have 1/2, 0. And 10, 1, our other key point, well, 10 times 1/2 is 5. So now it's going to be 5, 1. And there's our picture. So I have 1/2, 0, 5, 1. And we have one more transformation on this particular graph, and that is the +4. And at least think about, what does +4 do in your head? Well, +4 moves our graph up 4. The +4 is outside of the function, and we only have 2 points to really look at on this one. So the 1/2 0 is going to move up 4. And our 5 1 is going to move up 4. And even though my graph looks like it, we don't touch the y-axis. As we finish. This last graph actually has 4 transformations on it. But we can do this. The function that we're working with is the parent function that we're working with is the square root of x. And I'm going to put 2 of them on this first graph. So if that's going to be confusing to you, just don't graph the parent function and you can get the first transformation on this first graph and then we'll get the rest. But if you do remember the key points, square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. There's our square root function. But in this particular problem, we do have 4 transformations, and we can make this work for us. The first one's coming from the negative that's outside of the function. It's separate from the 3. What does a negative outside of the function do to the function? It reflects us over the x. I'm going to graph that on the same axis as the parent function. But 0, 0 is still going to stay 0, 0. But use your hand gesture, even though you can't see it on the video, use your hand gesture if you need to. This is going to become 1, negative 1. Instead of 4, 2, it's going to become 4, negative 2. Instead of 9, 3, it's going to become 9, negative 3. There's our reflection over the x-axis. Well, what I said is that the negative is separate from the 3. But that's what we're going to look at here next, is the 3. The 3 is outside the function. It's going to be a vertical stretch. And when we have a vertical stretch, what changes in the ordered pairs are the y values of the points. 0 times, by the way, it's going to be by a factor of 3. 0 times 3 is 0, so that's still going to stay 0, 0. But 1, negative 1, the negative 1 is going to be multiplied by 3. So it's going to be 1, negative 3. And the 4, negative 2, the negative 2 is going to be multiplied by 3. So it's going to be 4, negative 6. And the 9, negative 3, the negative 3 is going to be multiplied by 3, so it's going to be negative 3 times 3 is 9, negative 9. And there we have our second transformation. Leads us into our third transformation. Because I read the graph left to right, there is a negative underneath the square root. Well, a negative inside, I should say better, inside the function means that we're going to have to reflect over the y-axis. We've already reflected over the x, so now we're going to take that graph and we're going to reflect it over the y. The 0, 0's not going to change. But what's going to change is that 1, negative 3 is going to become negative 1, negative 3. And 4, negative 6 is going to become negative 4, negative 6. And 9, negative 9 is going to become negative 9, negative 9. And then our last transformation, we have the plus 2, which is outside of the function. We're going to take all those points from our green graph, and we're going to move them up to 9, negative 9 is, sorry, negative 9, negative 9 is going to become negative 9, negative 7. And negative 4, negative 6 is going to become negative 4, negative 4. And negative 1, negative 3 is going to become negative 1, negative 1. And 0, 0 is going to become 0, 2. And there's our picture. Yes.